Okay, good morning, students. I am going to start the class and you listen very carefully. And today I am going to revise the few topics in the light, reflection, and refraction. Previously, scattering, human eye, and colorful world, I revised. Now I am going to revise the few topics in the light, reflection, and refraction. You listen very carefully. Okay, is my voice clear, students? Light. Is it clear voice, students? Right. Our chapter name is light, reflection, and refraction. I am going to explain. Okay. Reflection and refraction. This chapter is already completed. Once I will revise the topics today. Okay. And you listen very carefully. Okay. Now, what we learn in the light, reflection, and refraction. Okay. Arun, thank you. And I am going to start. Okay. Right. First, light, reflection, and refraction. Some important points I will explain. I will revise the whole chapter once. Okay. And today and tomorrow we will revise this chapter. First of all, reflection and laws of reflection are what? Reflection and laws of reflection. First, reflection. What is reflection? And what are the laws of reflection? Okay, reflection means when light undergoes, for example, this is a light ray. Light ray is incidenting it here like this. This is the mirror, we can consider it is a polished surface, it is a mirror. Okay, and this is the normal drawn to certain point P. This is the normal drawn. Normal drawn means it is a line, it makes 90-degree with the surface. For example, this is a light ray which is incidenting like this. Sorry, this is the surface and the light ray is incidenting like this at here, and this is the normal drawn. Okay, and this is the mirror surface we can consider. One light ray we will take that is incidenting at this point like this. This is the incident light ray, and this incident light ray is making some angle with the normal, that is angle of incidence. After that, light will be goes back like this. This angle is said to be angle of reflection. Okay, this is about reflection of the light. Okay, what are the laws of reflection? What are the laws of reflection? The laws of reflection are the first one is the angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. And the second point is that incident light ray, comma, reflector light ray, and normal drawn are in the same plane. Okay, normal drawn are in same plane. Same plane means what? On the same surface. For example, we take the wall as one plane. One wall is as we can take as one plane. Angle of incidence. This is angle of incidence. This is angle of reflection. Okay, this is nothing but angle of incidence is equal to angle of reflection. Angle of incidence is equal to angle of reflection. These are the laws of reflection. Angle of incidence between what and what we have to take. Can anyone answer? Angle of incidence is angle between what and what? Angle of incidence is the angle between the incident light ray and the normal drawn. Angle of incidence is the angle between what and what? Angle of incidence is the angle between the incident light ray and the normal drawn. Right? Angle of incidence. Angle of incidence is the angle of incidence. I is angle between what and what? Okay, incident light and normal drawn. What is this? This is the reflector light ray. Okay, angle of incidence is angle between what and what? Angle between incident light ray and normal drawn. Okay, incident light ray and normal drawn. What is angle of reflection? R is the angle of reflection. It is angle between what and what? It is the angle between this one bn. Okay, angle between the reflector light ray and normal run. Reflector light ray and normal run. Okay, and this is about reflection. And now one question I will ask related to this reflection. For example, the question one is that, okay, I will see the question that the light ray is for example, if light ray is incident at an angle, if light ray incident at an angle of incidence, if a light ray incident if light ray incident on a mirror with angle of incidence with angle of incidence 30 degree, then find angle of reflection. Then find angle of reflection. Yes, students, write the answer in the chat box. Do it fast. Answer you should write in the chat box. We know that angle of incidence is equal to angle of reflection. That means we write R is equal to I. What is the angle of reflection equal to angle of incidence? What is the angle of incidence? What is the angle of incidence? We know now this. Or otherwise direct we can write. Write in the chat box, students. What is R? Angle of reflection equal to angle of incidence. In the question what they gave, Y is equal to 30 degree they gave. R is equal they are asking. Is it right? R is equal they are asking. Then what we can write here? I is equal to 30 degree. Then they are asking the R. What is the value of R? You know, according to laws of reflection, R is equal to 30 degree. Right now? Because R is equal to I. Is it right? Write in the chat box, students. Is it correct now? Okay. Next, let us go for the one more point. Now, one more question I am going to give. If angle between the if angle between the angle between the incident light ray and reflector light ray is 50 degree, then find the angle of incidence. This is our question. Can anyone tell the answer? Write in the chat box. What they gave in the question? The angle between the, this is the plane mirror. This is the mirror, and this is the normal run. Okay, and here the light ray is incidenting like this. It is reflected like this, right? The angle of incidence is I, angle of reflection is R. Then question, what is the angle of incidence? Can anyone tell the answer? Right, Shawan, 25 degree. Right, previous question answer also gave by the Sia, Chandra, Rahul, attendance they gave. Deepak, right? Deepak 25 degree. Priyanka Mato 25 degree. Right answer. Yes. Solution, let us go for the solution. What they gave in this, angle between the incident light ray and reflect light ray is 50 degree. This is incident light ray, is it right? And this is the reflector light ray. Angle between the two they gave. Right? What is the angle between the two from that figure? Angle between the two from the figure is what? I plus R. Is it right? Is it right? I plus R. I plus R is equal to what they gave? 50 degree. Is it right? Angle between the incident light ray and reflected light ray is I plus R. Is it correct? I plus R is 50 degree. Then, and one more thing they gave that, no, nothing they gave, just they are asking to find out the angle of incidence. But according to laws of reflection, what we know? According to laws of reflection, according to laws of reflection, according to laws of reflection, what you know? Tell me. Angle of incidence is equal to angle of reflection. This is substituted in above equation. Then I plus, in case of R also we write I, that is equal to 50 degree, right, from this equation. Then we write 2I is equal to 50 degree. Then finally I is equal to, we will get is 25 degree. Is it right? Okay. Is it clear? Writing is appearing or not? Write in the chat box, students. Is writing is clear? Yes or no? Writing clear na? Okay, let us go for one more problem. The problem is that a light ray incident, a light ray incident on a surface, on a reflecting surface, on a reflecting surface at an angle, at an angle 45 degree with the surface, then what is the angle of incidence and angle of reflection? Then what is the angle of incidence and angle of reflection? Angle of incidence and angle of reflection. This is our question. Write in the chat box solution. Do it fast, students. I'm expecting answer as early as possible. This is the revision classes. You should answer fastly. Deepak Singhu 45 45. Priyanka Mato 45. Any other answer? I am changing the question now. If angle of incidence is okay, okay, right, it is correct. Now I am changing the question. Just I am giving the 30 degree now. Okay, I am giving the 30 degree. Now you start the answer. I am changing the question. Now start the answer. What they gave here and what we have to find out. This is the mirror surface. This is the mirror surface. The light ray is incidenting like this, and this is the normal run. This is the normal run. This is incident light ray, and light ray undergoes the reflection like this. But in that, what they gave in this question? In this question, they gave the angle in the incident light ray with the surface. And a light ray is incident on the reflecting surface at an angle 30 degree with the surface. At an angle 30 degree with the surface. Right? Have you give the answers? I said to write in the chat box. 60 degree Deepak Singh. Very good. This is incident light ray with the surface they give. With the surface 30 degree. This is not angle of incidence, that you should remember. This is the angle between the incident light ray and the surface. This angle is not angle of incidence. Angle of incidence is this one. Is it right? Angle of incidence is the incident light ray and normal run. Angle of reflection is this one. Right? In the question, what they gave with the surface they give. But this normal green line makes 90 degree with the surface. Is it right? Now, incident light ray makes 30 degree means this I must be 60 degree because from total is I plus 30. I plus 30 should be equal to 90 degree. Is it right from the figure? I plus 30 is equal to 90 degree means I must be equal to 60 degree. Angle of incidence is 60 degree. If angle of incidence is 60 degree, then automatically angle of reflection also equal to what? How much? 60 degree. Because angle of reflection equal to angle of incidence. Right? Understood, students? Clear na? Yes, this is about laws of reflection. And the next one is I am going to explain one more point, that is image characteristics of the previous question. Write the characteristics of image forms by write the characteristics of image forms by plane mirror. What type of image formed by the plane mirror? Its characteristics required. Write the characteristics of image formed by the plane mirror. Very important question. Previous many times it came. The first characteristic, you start and writing the Chandra Mohan, right? Okay. You start writing the answer. What are the characteristics? Characteristics of image formation by the plane mirror. That first one is image is what? Image is real or virtual? Image is real or virtual? Image is virtual. Virtual means what? We can see but we cannot catch on the screen. And next, image is erected image, right? Image is erected. Erected means if you see your image in the mirror, upper parts appear as upper parts and lower parts appear as lower parts. right? That's why the image is erected. And the next one is image is head appears up, right? And image is laterally inverted. Laterally inverted. What is the meaning of laterally inverted? Left hand side appears as right hand side, and right hand side appears as left hand side. And that means if you will hit with the right hand, okay, you will hit with the right hand. In the mirror, it appears that you are eating with the left hand. That left hand side appears as right hand side, and right hand side appears as left hand side, and vice versa. Vice versa. Okay, this is image is laterally inverted. What about the size of image? Size of image is equal to size of image is equal to size of object. Size of object. Do you know what is the magnification? Magnification definition is what? Magnifying power or the magnification. Okay, magnification or the magnifying power. What is magnification? It is the ratio between height of image to the height of object. Height of image to the height of object. Okay, it is denoted with small m. Its formula is height of image by height of object. Now my question is that what is the magnifying power of plane mirror? Okay, in case of plane mirror, what is the magnifying power? Write in the chat box, students. What is the magnifying power of plane mirror? Huh? Image height is equal to object height, right? Height of image is equal to height of object. H2 by H1 here. But H2 is equal to H1 in case of mirror, plane mirror. That's why magnifying power, how much you will get? That means magnifying power of magnifying power of plane mirror is equal to magnifying power of plane mirror is equal to, can you tell one is it right? How many of you wrote in the chat box? Very good. Nishant Kumar Nayak, magnifying power of our plane mirror is equal to 1. Deepak Singh, good. Next, let us go for the next question. Right, you listen very carefully. We are discussing all important points in the chapter. That's why don't waste the time. Right, listen very carefully. Now I am going to explain the one point about the spherical mirrors. I am going to explain. Okay, in the reflection, spherical mirrors, plane mirror, plane mirror means whatever that we are seeing, our image in our house, that is the plane mirror, right? Now I want the spherical mirrors. Spherical mirrors are what? Spherical mirrors are what? These are the curved mirrors. How many types of spherical mirrors are there? Okay, these are two types, right now. These are two types. What are they? Concave mirror and convex mirror, right now. Concave mirror and convex mirror, right? How the concave mirror will be there? For example, you are seeing your image For example, you are seeing like this. Okay, this is your, for example, your images you are seeing in this part. In this you are seeing the your image like this there. This is the concave mirror. For example, like this there. You are seeing your image in this surface, on this surface. This is to be convex mirror. That means spoon hollow side will act as concave mirror, other side will act as the convex mirror. Okay, and now spherical mirrors are two types. What are the rules to draw the ray diagram for the spherical mirrors? Okay, let us go for the rules. Rules to draw the ray diagram. Rules to draw ray diagram. That ray diagrams are their image formations that are very very important, and these rules are very important to draw the ray diagrams. What are the rules? Very simple rules are there. For example, this is a concave mirror. Okay, concave mirror. Some basic points you should require to know, and that is the midpoint of the mirror is called as the pole, and the mirror is a part of circle. Mirror is a part of circle in the two-dimensional circle, but actually mirror is a part of sphere. That sphere center is called as the center of curvature. The distance of center of curvature from the pole is called as the radius of curvature. This R is called as the radius of curvature. C is called as the center of curvature. Okay, right. Now this is a line which is passing through the center of curvature and pole. It is called as the principal axis. This is called as the principal axis. Now we have to go for the rules. First we will take one ray. If that light ray is incident parallel to the principal axis, this line which is passing through center of curvature and pole is called as the principal axis. And if light ray is incident parallel to the principal axis, after the reflection passes through, sorry, after the reflection passes through what? Rules I am going to draw. Okay, look at here very carefully. This is a concave mirror. Okay, it's a concave mirror, and concave mirror, for that, if light ray is incident parallelly, if light ray incident parallel to the principal axis, this is the pole, and this is the center of curvature. The distance of center of curvature from pole is called as radius of curvature, and this is the principal axis. If light ray incident parallel to the principal axis, if light ray is incident parallel to the principal axis, after the reflection it passes through focus. After the reflection it passes through focus. This point is called as the focus, and the distance of the focus from pole is called as the focal length. Okay, this is the first rule. Second rule is that it is reverse to this. Very simple rule. That is, if the light ray is this is the pole, and this is the center of curvature, this is the focus. If light ray incident along the focus, okay, if light ray is incident along the focus, for example, exact reverse of this. For example, light ray is incidenting like this. Light ray incidenting along the focus. If the light ray incident along the focus, after the reflection it passes parallelly, that means it will go like this. Okay, and how it will go? It will go like this. You see here, here parallelly incidenting after the reflection passes through capital F, and along the capital F it is incidenting after the reflection passes through focus, right, like this. And next, one more rule, very simple rule, that third rule I am going to explain. The third rule is that if light ray passes through center of curvature, this is the pole, this is the focus, this is center of curvature. If light ray incident along the center of curvature, if the light ray incident along the center of curvature like this, okay, it is not necessary to incident like this, it can incident like this also. If the light ray incident on the mirror along the center of curvature, after the reflection it will come back in the same direction. Okay, why? Because the line joining the center and normal, center and one point on the mirror, this is only act as normal. Okay, this is only incident light ray and this is only normal. That's why the light ray will be reflected back in the same direction. In this case, angle of incidence is 0 and angle of reflection also 0. It is the case just like this. I will explain. This is a plane mirror. Okay. If light ray incident along the normal, this is a normal. If the light ray incident along the normal, after the reflection, it will go back along the same direction. Is it right? After the reflection, it will go back along the same direction. That means in this case, angle of incidence is what? Because this is only incident light ray, this is normal run. Angle of incidence is 0. This is only reflected light ray, this is only normal run. That's why angle of reflection also 0. Right? Not 90 degree here. This 90 degree is not angle of incidence. 0 is the angle of incidence. Why? This is angle of incidence means it is the angle between the incident light ray and normal drawn to the surface. Normal is this one only. Incident light ray that one only. That's why angle of incidence is 0. Some of the students they will think that angle of incidence is 90 degree, but it is not correct. Angle of incidence means we should not take with the surface. We have to take with the normal. Are you understanding the concept clearly? Okay, these are the rules to draw the ray diagram. These are for the concave mirrors. Right? These are the rules, whatever that we wrote here, that for the concave mirrors. Same rules can be followed for the convex mirror also. Right? How the convex mirror will be there, we will draw here for the convex mirror also. This is the convex mirror, right? And this is the reflecting surface. It is the reflecting surface. And now this is the principal axis. Okay, this is the pole and this is the center of curvature. Now the first rule is that if light ray incident parallel to the principal axis, after the reflection it passes through focus, but actually in this case what happens, the focus is on the right side. Okay, there is one relation is there between the radius of curvature and focal length. You see here, center of distance of center of curvature from the pole is called as the radius of curvature. Distance of the focus, if capital F is called as the focus, capital F is the focus, and capital C is the center of curvature, and capital P is the pole, and F small f is the focal length, distance of focus from pole, and distance of center of curvature from pole is R. And here light ray which is incident on the mirror, it never crosses the mirror, it will be reflex, means it will go back. Either ऐसे आ सकता है नहीं तो ऐसे आ सकता है. Then how it will goes, then for that we have to know the normal run. You should join the center of curvature and center of curvature one point on the mirror. This will become normal. This red line is the normal at here, and this will become angle of incidence. This is the angle of incidence. Then what will be the angle of reflection? Right? What? How much, with how much angle it will incident? With that much angle it will be reflex. This is the reflector light ray, and this reflector light ray appears to be coming from the center of curvature. Okay, reflected light ray appears to be comes from center of curvature. Okay, is it clear, students? This we have to do the extension at here like this. Shit, it is in duster mode. You do the extension for this reflector light ray. This is the reflector light ray, and this is incident light ray. Now, according to the first rule, if the light ray incident parallelly after reflection passes through focus, here light ray is incidenting parallelly, then after reflection whether passes through focus or not, right? It will also passes through focus. It not passes through focus. It appears to be coming from the focus. It appears to be coming from the focus. Okay, this is the first rule. And the second rule is that if the light ray incident in such a way that it passes through focus, then how the light ray will goes? This is the center of curvature. This is the focus. Just very simple that I am telling. Okay, the light ray is allowed to incident like this, and it is incidenting that in such a way that it passes through focus. And after the reflection, it passes through parallel to the principal axis. It will go like this. This is happens. It is exactly opposite to this. This is incident light ray, and this is reflect light ray. Here, light rays appears to be incident. Light ray is incident in such a way that it passes through focus. After reflection, it passes parallelly. Okay. Next, third one is the third rule is that third rule is that this is the pole, this is the focus, this is the center of curvature. Okay, if light ray is incident in such a way that it passes the center of curvature, like this, then after the reflection, what happens? It will go along the same direction. Because here angle of incidence is 0, angle of reflection is also 0. These are the rules to draw the ray diagram. Is it clear, students? This is the for the convex mirrors. And based on this, you have to draw the ray diagram. Actually, what happening in the concave mirrors after the light ray is parallelly incidenting, after the reflection really passes through focus. But here, when light ray parallelly incidents, after the reflection appears to be passes through focus. Here, light ray, if it is incident on the mirror through the focus, after the reflection passes through parallelly to the principal axis. Here, light rays appears to be incident along the focus, and after the reflection passes parallel to the principal axis. This is the principal axis. Right? If light rays incident along the center of curvature, it will reflect back along the same direction. If light rays appears to be incident along here, it is not really passes through center of curvature. Here it is appears to be incident along the center of curvature. Then after reflection, it will go back along the same direction. Okay, these are the rules to diagram. The other diagram. Okay, have you understood, students, till now? Is it clear, students? Is it clear? 1 minute, I am coming. Okay, Moti. Right. I'm going to continue. Now, the next topic is that what is the relation between the focus and radius of curvature? Already I give relation between the focus and radius of curvature. What is the relation between the radius of curvature and focus? Relation between the radius of curvature and focus. The relation between radius of curvature and focus. Radius of curvature and focal length. Relation between radius of curvature and focal length in mirrors, right? In spherical mirrors. Can anyone write in the chat box? Write in the chat box. Relation between the radius of curvature and focal length. That is R is equal to 2F, right? R is equal to 2F. Radius of curvature is the twice of the focal length. Radius of curvature is the twice of the focal length. Next, in the mirror formula, actually, image formation by the mirror will be like this there. For example, this image formation by the mirror you should learn properly. Okay, image formation by mirrors. How image forms in the mirrors. Just you see that if object is at infinite distance, where is the image? How to find out that? For example, this is the mirror, concave mirror. If object is at infinite distance, if object is at infinite distance, light ray incident parallelly. Okay, when the light rays are incident parallelly, you know that when the object is at infinite distance, okay, light rays comes parallel to the principal axis. After the reflection, they passes through focus. After the reflection, they passes through focus. They will meet at a point. That means if object is at infinite distance, this much height is there, and then image is point size. That means point size image is called as the diminished image. Small size image. Diminished image is formed. Okay, like this. Object is at infinite means object at infinite. Then where the image is forming? Image forms at the focus. Image at the focus, right? And like this we have to draw the ray diagrams. For example, object is back of center of curvature. Then what is the draw the ray diagram and how the image will be forms. Then this is the focus, this is the center of curvature. For example, object is at here. This is object. OJ is the object. Then you take one light ray parallel to the incident, parallel to the, you take one light ray that is incident parallel to the principal axis. After reflection, where it will goes? It passes through focus. And one more light ray you take in any way that it may passes through focus, okay, or it may incident at the pole, right? Then they will meet, the reflected light rays will meet at a point like this. For example, I am taking through the focus, then after the reflection it will come back parallelly, you know the rules. Then they will meet at a point, and that means image forms at here. Where the light rays meet with each other, there the image will be forms. That means this is the image, because the reflected light rays from the mirror meet at a point, there the image will be forms. This is the image. Okay, this is the object. IG is the image. Where the image will be forms? When the light rays are incidenting on the mirror, after the reflection they are meeting at a point. At that point the image will be forms. That means if object is back of center of curvature, then image is between the C and F. Right now, image is between C and F. Like this, we have to draw the diagram. And the next one more point I am going to give, that if object is at the center of curvature, this center of curvature and this is the focus. For example, object is at here. This is the object, and we are taking the light rays. One light ray we will take parallel, okay, and after the reflection it passes like this, right? One more light ray you take, this passes through focus, then after the reflection it will come back like this, and they are meeting at a point, and then image will be formed at here. Now in this case what happens? The reflect light rays are meeting, one light ray reflect like this, another light ray reflect like this, they are meeting at this point, and this is the object and this is the image. In this case what happens? If object at center of curvature, then image also at center of curvature. In this case what happens? What are the characteristics? Image is real or virtual. Really light rays are meeting with each other here, that's why it is real image. Real and diminished image forms at here. Here object is behind center of curvature. Then where the image will be forms? Image between C and F, right now. And image is real, inverted, right? Here highly diminished, here diminished. These all things we discussed. You practice properly. Once again I am revising just. And image is C. Image and object both are at the same point. Then image is real and inverted. Image is real and inverted. Inverted means reverse image forms. You see here, image is real, inverted, and same size. This is the most important point. Same size means in this case the magnifying power is 1, minus 1 it is. Why the magnifying power is minus 1? Magnifying power formula is height of image by height of object. But in this case height of image is minus h, height of object is plus h. Why? Because all the distances above the principal axis we have to take positive, and below the principal axis we have to take negative. Image forms below the principal axis, object is above the principal axis. That's why object height we have to take positive, image height we have to take negative. That is image height by object height, negative by positive. But the both are same. That's why we are getting the minus 1. This magnification is minus 1 when object is at the center of curvature, right? The easy question they will ask, but with the testing they will ask. Then in case of concave mirror, the magnification is minus 1. Related to that, draw the diagram and explain what is the position of object and image. Such type of questions they will, with the testing they will ask. Okay, same questions they will ask, but somewhat testing will be there, right? And direct question they will not ask. Now let us go for next fourth one. Next we can take that if object is between the center of curvature and object is between the center of curvature and focus. If the object is at here, where the image will be forms. Okay, if object is at here, the image will be forms like this. One letter you take like this parallelly after the reflection passes through focus. Okay, rules are same. And one letter you may take it is incidenting at here, and after the reflection it will be meet at here, and the letters are meeting at here, and here the image will be forms. This is the image. What happening at here, this image is this one, object is this one. Now object is in between the C and F. What is the location of object? Object is in between C and F. In between C and F. Where is the image? Image is back of C. Is it right? Image is back of C. Behind C. Okay. What about the size of the image? Here the size of image is more than the size of object. And say enlarged image will forms. Enlarged image. What is the nature of image? It is that it is real or virtual. It is a real. Like this we have to draw the diagram. One more I will draw. If object is at the focus, where the image will be forms. If the object is between the focus and pole, then where the image will be forms. Like that. Two more diagram I will draw it here. Like this we have to draw the diagrams, and this is very easy to draw the diagram. If you understood, then it is very easy. If you not understood, then it is very difficult to draw the diagram, right? Just you have to use the rules to draw the diagram. If you know that rules, then you can draw easily. Okay, are you understanding, students? Right. Now you see here, this is the focus and this is center of curvature. If object is at the focus, then where the image will be forms. If object is at the focus, one letter you take parallelly, it will passes through focus. And one letter is you take like this, it may incident like the center through the center of curvature, then it will come back in the same direction. You may take any letter, either incident at the pole and it will come back like this. You may take any two letters, then by taking two letters we have to explain the image formation. Understood, students? Right. Now let us see. One more letter you take that is allowed to incident at the pole, and after the reflection it will go like this. Then these reflector letters are parallelly going, and these reflector letters never meet at here. That means image they will go up to infinite distance. Then object at focus means then image will be at infinite, right? You know, first we discussed when image is infinite, object when object is at infinite, image is at the focus. When object is at the focus, then image is at infinite distance, right? Last diagram is very important for the concave mirror. Convex mirrors, for the convex mirror, this much diagrams are not there. Not there. Only two diagrams are there. Convex mirror always forms the virtual image. Okay, thank you, students. I am closing the class because of network problem. Okay, thank you, students. I am closing the class because of network problem. Mm.